Hello friends, I welcome all of you. In this video, I will talk about type of traffic in a network. It's very important topic and I want to discuss it. There are three type of traffic we have. First one is unicast, then broadcast, and then multicast. Unicast, like the name says, one to one. One sender, one recipient. One copy, the same will be received by the recipient. Okay, it means direct communication or sending of an email or file transfer. So here point to note is that both sender plus recipient, these can be within the segment or within the LAN or anywhere in the world. That is our WAN. As long as they have the IP connectivity, unicast communication can be established. Remember this thing. This thing is important. Okay, both sender and recipient can be within the network segment or outside the network segment. All right, and the internet traffic, it is using unicast only. It doesn't use broadcast, doesn't use multicast. I'll explain you later on. But at this moment, just understand that internet uses unicast only. So if there are 100 million YouTube videos being watched per hour, that would mean these many copies will be generated by the YouTube servers. That would mean CPUs will be utilized at very high scale, memory, input output resources, replication servers, GPUs, graphical processors, more importantly links will be utilized. So just imagine the scalability of their infrastructure or strength, or how big is that. Okay, so this is how it is. That is why they are so big, so rich as well, because they are catering these many users in the world. This thing is now done. So next is broadcast. Broadcast means one to all. Whosoever is part of your network segment, that is LAN, will receive the traffic, whether they want it or don't want it. Okay, so let's say a politician giving lecture or making a speech on the rally. There are 100 plus people in a gathering. Everybody is hearing. Now it's hearing, not listening. Means they may not be paying attention to him, right? But this is an example of broadcast traffic. So everybody will hear it. And the use case is ARP and DHCP. ARP is Address Resolution Protocol. That is when IP to MAC conversion is needed. You will learn more about it in the switching section. At this moment, just understand that ARP uses broadcast traffic, and DHCP, which is Dynamic Host Configuration Protocol, which allocates IPs dynamically to users, this also uses broadcast traffic. Okay, this is the first server people use on their devices, because devices need IP addresses automatically, right? And this is the DHCP server which gets them the IPs. So this is an example of broadcast, and in this case sender and recipient, these need to be part of within the segment, within the LAN. Remember this. If recipient is outside the LAN, then broadcast cannot cross that, because router doesn't forward the broadcast. It drops. It will receive it. It doesn't forward. Okay, this thing should be known to you. Very important point here. I will discuss in the next slide. Okay, now multicast. So multicast, like the name says, one to many. If there are, let's say, 100 users, but out of those 100, only 2 are interested, this one and this one, then these will get the copies of the traffic. Let's say this one is sender, all are recipient, but only these 2 are interested. Then this is an example of multicast, means one to many or to group of interested recipients. Means traffic will be sent on demand basis. Unicast is again also on demand, means you initiate the traffic to genuine host or genuine recipient. And broadcast is like there are workstations who are idle, don't want to receive, but you make a broadcast, you send it to everyone. That is why I mentioned here network segment, all devices in a network. So here it will be group. So remember that multicast needs to be configured on the routers or on the layer 3 devices. So it's not so easy to configure. This thing should be known to you. It's not easy. And internet has so many ISPs. So all the ISPs will not sit together and configure multicast traffic for a certain use case. It will be waste of time for them and waste of resources. So it is not feasible to use multicast in the internet. And the example of multicast will be like you have a annual general meeting of your company. The CEO wants to give lecture. There are, let's say, 10,000 employees who should be listening to him. But some employees don't listen, they might be busy, right? So only, let's say, 1,500, they've decided to pay attention to whatever he's saying. So what is actually done here? Whatever he says or speaks, that copy is kept in a multicast server. So whosoever needs the copy, the request will be sent by them. Of course, all the employees will be sent a web link. Okay, they'll click on the web link and then the request will go to router. A router will then send them a copy. I'll discuss in the next slide. So this is an example of multicast. So here sender as well as receiver, these can be within the LAN or in the WAN. Okay, video streaming is main in online conferencing because you cannot afford to have so many copies. Here number of copies will be less of the data. It will be huge here. It will be very less. If there are only 3 users, right, you do multitasking, like send one unicast traffic to, let's say, recipient number 1 and you send one to recipient number 2, right? So here resources utilization is less. Here it's very huge, and in multicast it is a need basis, but it's complex to configure. So let me delete this. Now you see that this is a diagram which I have prepared. Let's say that let's discuss the unicast traffic. This one is a sender number 1. So it wants to send some data over to this one. This is, let's say, server number 2. So it will be like this, unicast. Or if it wants to send traffic over to this server 4, it will send over to this. This is a unicast. So one copy for this one and one copy for this one. Again, these are 2 different connections. Second is broadcast. Let's say that this one is server 3. It makes broadcast. So who will receive? this one will receive, this one will receive, and this one will receive. After all, router is also an end host. Okay, so 3 copies, 1 copy to this, and then this one will generate 1 copy for this, and this switch will send 1 copy for this. 1 2 3. So if this one was not interested, so it's a waste, right? There was no need to send. And let's say that this host, it wanted to get broadcast from this, but it will not reach here. Okay, because this router, it drops the broadcast. You have to do additional thing, that is directed broadcast, means that is advanced concept wherein you will use IP helper address thing, but forget about in the basic router drops the broadcast. This is the thing I want to explain you. So broadcast works within the LAN. So just find out how many LAN we have. This is L2 switch, okay, and this one is L2 switch. L2 means these don't have the capability of routing. So LAN, this is your first LAN, means all 4 devices, this and this router having this interface, part of LAN number 1. And where is second LAN? Second LAN is this. Alright, this interface plus this switch, of course this device as well. This is LAN number 2, and third is this one. Okay, LAN number 3. So there are 3 broadcast domains. The answer is broadcast works within broadcast domain. This is very good example of broadcast traffic. Now this multicast. This one is a multicast server, and this host wants to receive traffic, and this host. So they will make a request. Okay, means we need to configure multicast commands on this router. So this router will have a copy of this one. First of all, understand that if this device needs to listen to the CEO, he'll make a request, and the request will go to router, and router will send a copy. Okay, this is the concept here. So whosoever needs will send, and now this one wants to get the copy, it will make a request over to router, and then router will respond with the copy. So here resources are very less utilized because only 2 requesters were there, even if we had 5 users, right? It's on a demand basis. This is an example of multicast traffic. There is a complete course in that. You may search. It's very big. It's not so easy. So it requires configuration. That is why it is not used in internet. Remember, it is not used. And here the source, that is sender and recipient, both can be part of LAN as well as outside the LAN, because this server was outside the LAN for this, right? Again, this server was part of LAN 1. This one was part of LAN 2. Okay, and there is a router which does the inter-LAN communication. So both sender and recipient can be part of LAN and WAN. Note in multicast. So that is it. Very simple thing to understand, but it is important. So thank you so much for your time. Have a nice day.